Section 12.6. Surface area of pyramids and cones. A pyramid is a solid figure that has a... Who has some ideas of what this could be? Okay, what think? Okay, so people think one person thinks it's a square. Yeah. Okay. A rectangle, good. AJ? Yep, that's what David said. You can also have a triangle. Okay, you can also have anything that is a polygon. It's a polygon. So a pyramid has a polygon for a base and triangles for sides. And triangles for sides. Anthony, sit down. So, pyramids are named all about their what? Base. Named all about their base, says. They're named all about their bases. A pyramid only has one base. And lateral sides. Lateral faces or lateral sides. So when you're dealing with a pyramid, it's going to have one base and lateral sides. So this would be a... Well, I'll get to that in a second. A square pyramid has a what for a base if it's named all about their base? Yeah. A square. Anthony, please be quiet. It's a square base. So here would be, just imagine that the blank part here that I don't have, that would be its base. See how it's a square? Okay, that would be a square triangle. You. Okay. A pyramid has a square for a base, and a triangular pyramid has a what for a base? A triangle. So this would be a triangular pyramid, like that. Okay. Whoa. With a triangular pyramid has a triangle base. Okay. Can you read that, please? Read that out loud for everybody. So the slant height is slanted. Okay, the slant height is slanted, not to be confused with the altitude. Altitude would be if it was straight up through the center of the pyramid. So as I'm looking at this guy that I hastily made last period, the altitude is going to be the distance from my table to the peak. All right, from the table to the peak. However, a slant height is going to take up more space. Okay? Yes, it is. Thank you. So if I were measuring from Chasten's desk to my finger, it's 36 inches. Okay? Imagine that we have, here. Imagine that there is this is the apex, and we have a triangle for each face, and this is going to be a rectangular prism. Imagine that each of the corner of Chasen's desk has, Juliet, you with me? Okay, because I'm showing something and you're writing something on the top of your notes. So are you imagining this triangle that's going from here to here to here? Okay. So if it's 36 inches to the top, if I were to try to get this to be 36 inches as a slant height, I didn't move my fingers down a little bit, but see how it doesn't reach the bottom of his desk? Okay, it's going to be longer. All right, it's going to be longer than that. So your slant height is going to be longer than your altitude. And it's going to give you the altitude, and when they do, it's going to look like this first one on the left. It's going to be a 90-degree angle coming from the very middle of the base. Okay, it's coming from the very middle of the base. The slant height is going to be shown like this, and it's going to be a 90-degree angle at the base, and then it's going to go to the apex. So that's the difference. If I was to draw an altitude here, that would be an altitude. See how it goes into the middle of the base? Okay. Uh-oh. That is squiggly lines. Let's see if this works. Yes! Did you read the second part? Okay. Surface area of a pyramid is the sum of all the areas of its base and also lateral faces. So we're going to find the surface area of the triangular pyramid below. Oh, and also, see how this, right there, on the test Friday, you will have formulas given to you. But you need to know which one goes with what. Okay? You need to know which one goes with what so you know for certain that you're using the correct one. These two is the area of a pyramid. Okay? That's what you need to remember, that if it's sides squared for a base and each side area equals, well, you should know, you should recognize this, like recognizing that as being the area of a triangle, 1/2 base times height, that's what you need to know. But you're going to be given that, but you need to remember that's what it's associated with. So the base of this is going to be just the side squared because it is a square, and they gave us only one measurement, which is 14. Let's give this inches. 14. So it's just 14 times 14. So I have 14 squared. And since we can use our calculators, what is that? 195? Close. It's 196. Inches squared, because we are in 2 dimensions. We are in 2 dimensions. I'm not done. 14 squared, that's all I need to do to get the base, because the base is a quarter. And I have 196 inches squared. Now, a lot of you, this period and last period, probably the next couple of periods, we're having the same issue, where on your homework, you were doing something squared, and then, rather than having it be a unit squared, you were squaring that again. They were squaring 196. No. You already took care of that. It's showing that the unit is unit squared. Yes? Because that's the side length of our square. Our square base. Does yours look? Yeah, it does look like that. That's where we got 14. Because do you see how that square, what would it be? See how that square pyramid has 14 for each side? Okay, the base is 14. So 14 squared. Then we have each side times 4. We have to multiply it by 4. Each side, what is each side? Okay, it's 1/2 base times height. So it's 1/2, base is 14. The height is 25. So I have to do 7 multiplied by 25. What'd you get? Okay, yeah. So 175 inches squared. Okay, so I have now had the sides. That's just one side. It's just one. Yeah. So I have to do 175 times 4 because I only took care of one of the sides. And, didn't you just give me 175?
Yeah, and then I added them together and
Got it, okay. Because we had to multiply it by 4. You see how this square pyramid, there's 4 sides? Okay, that's why we had to multiply it by 4 to get them all together. So I'm going to take 175, which is each side, times 4, and what was it, sir?
for which one? That's 175. I got 175 and then 371 for added together.
371. That's not possible.
No. Yes, minimum of 400.
700.
700.
Squared inches. Yeah, you can't multiply a multiple of 5 and have a 1. It's always going to be a 0 or a 5 in the ones digit. So I add them all together, and what do you get? You get 896. Yeah. 896 inches squared, which is the whole surface area. Really?
Oh, he just said that.
Because I don't look at that clock. A cone is, yes, wow, the clock's broken. Get over it.
What time is it?
A cone is another three-dimensional shape. Most cones you see have a circular base, and the formula for this surface area of the cone is this. The base is 2 pi r squared. It's just pi r squared. Because pi r squared is, okay, here's something. The radius is being squared. Well, how many dimensions are we dealing with there? 1 or 2? Something squared. It's 2. It's 2. You're dealing with 2 dimensions. You're finding the surface area of an object. 2 dimensions. It's a plane. Then we have the lateral surface, which is pi r, and then the slant height. That cursive L is the slant height. So here's a cone. Okay, here's a cone. It's going to be circular as the base. The slant height is going to be where this fold is right there. And you have to multiply it also by the area that this invisible circle is taking in this cone that I'm holding. Okay? So let's find what it is with this one. We have all about our base, which is going to be pi r squared, which is going to be pi 5 squared, which is 25 multiplied by pi, which we're going to use 3.14 today, please.
Oh, dang it.
We're going to use 3.14. We're going to round to the nearest 10th, I think your homework is. It is round to the nearest 10th. So 3.14 times 25, 78.5. Ooh. 78.5 meters squared. And the lateral surface, yeah, this is, it's just formulas. It's pi r and then L, which is going to be pi, radius is 5, and then the slant height is 13. 5 times 13 is going to be 65. 65 times pi. You have to write down your calculations. If you just write this here on your homework tonight, if you just write that and then the answer, that I can see what you did or didn't do right. You mean this? No, not never mind. You have a question. Let me answer it. No, I do want you to show your calculations, because if you really mess up, I want you to be able to come and bring that to me tomorrow morning and be like, okay, what was I doing wrong here? I got all these wrong. And if you show your work, I can say, boom, this is wrong, boom, this is right, boom, this is wrong. So what is 65 times 3.14, sir? 204.1. Hmm? .1 meters squared. So now I have to add those all together. I gotta add that base. 78.5 plus 204.1, 204.1. That comes out to be 282.6 meters squared. Yeah. Multiply and add together. Yes, sir.
Who asked that question last night on that photo? I don't understand any of it.
Me, I asked that. What does it matter?
I don't know.
So.
It was me. I was posing as a student trying to show you guys that I want questions. All right. That's all she wrote.